Hi everybody, in this video, let's look at your Form 5 at Math Chapter 5, Probability Distributions. In this video, let's look at discrete random variable and continuous random variable. So, how do we differentiate whether a given variable is a given random variable is a discrete random variable or continuous random variable? Maybe you can think this way. For discrete random variable, we can count it. For continuous random variable, we do not count it, but we measure it. Let me give you an example. Let's say you toss a coin for 10 times. Okay, I change it to 5 times. You toss a coin for 5 times. X represents the number of times you get a tails when you toss the coin. So what is a possible random variable? It can be 0 time, it can be 1 time, 2 time, 3 time, 4 time, and maximum the number of time will be 5 times. Why? Because you just toss it for 5 times. So do you notice that I counted it just now? 1, 2, 3, 4, 5, and definitely it can be 0 as well. So in this type of situation, we call this as discrete random variable. It cannot be 1.2 time, it cannot be 1.5 time, 1.52 time like this. It is not possible. So this type of random variable, we call it discrete random variable. Whereas for continuous random variable, we cannot count it, but we can measure it. For example, let's say I have a class consists of 10 students. And given that their body masses is from, maybe I write this one for you first, is from 50 kilogram to let's say 60 kilogram. So what is a possible random variable? Can I write this way? Let's say X is the body mass of the student. So can I write like 50, 51, 52, 53, and so on until 60? Is this correct? No, this is not correct, right? It is possible to get 50.5 kilogram. It's possible to get 51.2 kilogram, even 51.25 kilogram. It just goes continuously. If I write like this, it means that is it not possible to get 50.5? It's only possible to get 50, 51, 52, 53, and so on, which is not correct. So this type of random variable, we call it continuous random variable. So I cannot write this way. So I need to write this way. So let's say X represents the body mass of the student from 50 kilogram to 60 kilogram. So this is a way how we represent the continuous random variable. Okay, now hopefully you understand what is discrete random variable, which we can count it, and what is continuous random variable. It just goes continuously. We do not count it, but we can measure it. Now let's look at some example. Let's look at this example number 1. State whether each of the following statement indicates a discrete random variable, which we can count it, right? Or continuous random variable. This one we measure it. Express a random variable in set notation. So we have two things to be done. First, we want to differentiate whether the given random variable is a discrete random variable or continuous random variable. And second, we want to represent it using set notation, just like what I did just now. Okay, now let's look at part A. The number of times of buying apples from a food store if a woman goes to the store for 4 times. Okay, now before I tell you this is discrete random variable or continuous random variable, let me represent this in set notation first. Let's say X is the number of time buying an apples from a food store if a woman goes to the store for 4 times. Okay, try to think. What is the possible number of time? It can be 0 time, 1 time, 2 time, 3 time, 4 time. Is that possible to get 5 times? No. Why? Because the woman just go to the store for 4 times. So the maximum can go is 4 times, and it can be 0 time as well. I mean, the number of time buying an apples. Maximum is 4 times, and it can be 0 time as well. Means that she goes to the store for 4 times, but every time she does not buy an apples. Okay, now, so since we can count it like this, like what we did just now, so this is discrete random variable. Okay, now how about B? The height of 100 durian trees in an orchard are from 3 meters to 5 meters. Can I write like this? Let's say X represents the height of the tree. For example, 3, 4. Okay, let me write together with the unit. 3 meters, 4 meters, and 5 meters. Is this correct? No, this is not correct, because it is possible to get 3.1 meters, even 3.15 meters, 3.16 meters, and so on. It's just go continuously, which is different from just now, which we can count it, right? So this is not the way, not a right way to represent this random variable. So we can represent it this way. X is from 3 meters to 5 meters. Okay, so this is the right way to represent this type of random variable. So we do not count it, right, but we can measure it. So this is continuous random variable. Now let's look at part C. The number of students getting grade A from a samples of 10 students. So we can count it, right, this time. 1 student, 2 students, 3 students, and so on. Maximum 10 students, and it can be 0 student as well. So let me use X to represent the number of students getting a grade A from a sample of 10 students. So it can be 0 student, means that nobody get A. So 1 student, 2 student, 3, 4, 5, 6, 7, 8, 9. Maximum only 10 students, because the sample only consists of 10 students. It's not possible to get 11 students, and it is not possible to get 1.3 student, 1.35 student, right? So for this type of random variable, this is discrete random variable. We can count it. Discrete, this is C-R-E-T-E, discrete random variable. Okay, now hopefully you know how to differentiate what is discrete random variable and what is continuous random variable. Now let's look at example number 2. This is finding the probability of a possible outcome. Bag P contains 2 green marbles and 3 yellow marbles. Bag Q contains 3 green marbles and 2 yellow marbles. A bean, this one I should write a marbles. Okay, a marbles. Since this is marbles, so here will be marbles as well. A marbles is selected randomly from each bag if Z represents the number of yellow marbles selected. So how about, let me summarize this whole situation for you first. So for bag P, we have 2 green and 3 yellow. For bag Q, we have 3 green and 2 yellow. List down all the possible value of Z. Okay, Z represents the number of yellow marbles is selected. Let me draw a tree diagram to help you to visualize the situation. Now I have bag P. Okay, so I only have 2 colors, yellow and green. Bag P. So how about bag Q? Same thing, green and yellow. So it will be green here, yellow over here. Or let me write yellow first. Yellow, green, yellow, green. Okay, so for this branch means that yellow, yellow, you get yellow marbles from back Q, from back P, and you also get yellow marbles from back Q. So for this one, it will be yellow, green. It means that yellow marbles from back P, green marbles from back Q. So okay, these are all the possible outcome. Now, what is a possible value of Z? It can be 0 time, which is green, green. You didn't get any yellow marbles, so it can be 0 time. It can be 1 time, right? 1 times of yellow marbles, which is green, yellow, or yellow, green. And it can be 2 times as well, yellow, yellow. This is all the possible value of Z. It's not possible to get 3 because you only pick for 2 times, right? 1 times from each bag. Okay, so the answer for A will be this one, 0, 1, and 2. B, determine the probability distribution of Z. So we want to find the probability distribution of Z, means that we want to find probability of getting 0 time of yellow marbles, probability of getting 1 times of 0 marbles, yellow marbles, and probability of x equal to 2 means that getting 2 times of yellow marbles. And you will notice that this is all the possible outcome, right? If we calculate it correctly, when we sum we find the sum between, we find the sum among these 3 probability, you will get 1. Now let's see, how do we find the probability for each of them? It's actually very simple. Before this, let me fill in the probability of getting yellow marbles and green marbles here first. So for bag P, I have 5 marbles total, right? 2 green, 3 yellow. So total will be 5. Here will be 5 as well. Okay, and I have 3 yellow marbles. I'm going to write 3 over here, and this is 2. Always make sure that the sum of the probability between all the branches here will be equal to 1, right? So 3 plus 2 is equal to 5 over 5, which is equal to 1. If this is not equal to 1, you have to, maybe there's some mistake, you have to double check it again. So how about Q, back Q? Same thing here, I have 5 marbles. So I'm going to write 5 over here, 5 over here. I do the same thing for the rest. Yellow, I have 2 marbles, 2 yellow marbles. Green, 3. Same thing, after writing the probability, make sure that the sum of them is equal to 1. Yellow marbles 2, green marbles 3. Okay, now let me write over here. This is answer for example 2. Probability of getting 0 times of yellow marbles. So it will be green, green, right? So it will be 2 over 5 times 3 over 5. Which is 6 over 25. Now, how about probability of getting 1 type of yellow marbles? So this time you have to be more careful. It can be yellow, green. It can be green, yellow as well. So we have to find the sum between these 2. So for yellow, green, it will be 3 over 5 times 3 over 5. This is 3 over 5 as well, right? Okay, yes, correct. 3 over 5. Plus green, yellow. 2 over 5 times 2 over 5. Okay, this will give us 9 over 25. How about this one? 4 over 25. So the sum between these 2 will be 13 over 25. Now, let's look at the last one, which is probability of getting 2 times of yellow marbles. Let me write over here. X is equal to 2. So there's only one possible outcome, which is yellow, yellow. So it will be 3 over 5 times 2 over 5. So 3 2 you will get 6, 5 5 25. Now if you want to double check whether we calculated all the probability correctly, you can find the sum between these three. It should be equal to 1. If it's not equal to 1 means that we did it incorrectly. So 6 over 25 plus 13 over 25 and plus 6 over 25, okay, equal to 1. So this means that we did it correctly. Now let's try one more example. Two fair dice are rolled simultaneously. We have two fair dice. If x represents the difference in value of the number shown by both dice, what does it mean? If let's say first dice you get 1, second dice you get 6, the difference will be 5. Okay? If let's say for example first dice you get 4, second dice you get 3, the difference will be equal to 1. Okay? Now construct a table for the probability distribution of x. So first we need to know what are all the possible random variables. It can be 0, right? It can be 1, it can be 2, it can be 3, it can be 4, it can be 5. It cannot be 6, right? Why? If you want to get the difference between the two numbers shown as 6, it means that, for example, 0 and 6, this is not possible to get 0, or maybe 1 and 7 is not possible to get 7, right? So the maximum is only 5. The minimum is 0. Okay, how about let me draw a diagram to help you to visualize the whole situation. Okay, so now each dice will give us 6 possible outcomes, right? 1 2 3 4 5 6. So what I'm going to do here, I'm going to draw 6 vertical lines to represent the 6 possible outcomes for the first dice. 1 2 3 4 and 5, and the last one will be 6. Okay, now let me draw a horizontal 6 horizontal line to represent the 6 possible outcomes of the second dice. 1 2 3 4 5 and 6. Okay, now this is first dice and this is second dice. This is 1 2 3 4 5 and 6. Do the same thing for the second dice. 1 2 3 4 5 6. Okay, all the intersection point here are all the possible outcome. So for example, this is 1 6. This means that first die we get 1 and the second dice we get 6. This is 1 5. It means that first dice we get 1, second dice we get 5. You will notice that the difference between them only can be 0 until 5, right? If for this pair 1 6, the difference is 5, right? 6 minus 1, which is equal to 5. And how about this one? 6 4, the difference will be 2. You can try to look at every intersection point here. You will notice that the minimum, the difference is 0. For example, 1 1 2 2 3 3. The maximum is only 5. It's not possible to get 6. Okay, we want to construct a table for the probability distribution of x. So what do we need to do? We have to construct a table so this is 0 time, sorry, not 0 time, 0, different 0 means that same value, different between them 1 and 2 3 4, and the last one a little bit big is okay. 1 2 3 4. Hey, sorry, let me erase this one. 1 2 3 4 5. Okay, I don't need this. So x, this is for x, and this is a probability. So it can be 0, 1 2 3 4. Oh, sorry, actually I need that another column which is for 5. Let me add in here. Okay. This is for 5. Okay, now we want to calculate the probability for each of this. So we have to calculate 5 times, 6 times. 0, 1, 2, 3, 4, 5. So it's actually very easy. We can just use this diagram to help us get the answer. Let me show it here. Let's look at the first one. P x equal to 0 means that both values shown are equal, no difference. So it can be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So total we have how many possible outcomes? 6, 6, you will get 36. There are 36 intersection point here. It means that 36 possible outcome. So I'm going to write, how about, let me write over here first. $36. 1, 2, 3, 4, 5, 6. 6. So if I simplify it, I will get 1 over 6. So how about P x equal to 1? The difference must be 1. So this time you have to be careful here. So 1 you can pair with 2. 2 minus 1 is equal to 1, right? And start from 2 you need to be more careful. 2 it can be paired with 3. 3 minus 2 is 1, right? But it can be paired with 1 as well. Why? Because 2, 1 also different 1. Okay, so 3, 3, 4, 3, 2. 4 it can be 4, 5. It can be 4, 3. 5 it can be 5, 6. It can be 5, 4. All of these their difference is equal to 1. 6 it can be 6, 7, no, it's not possible to get 7, so there's only 1, which is 6, 5. Now, how many possible outcomes here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 10 over 36. So if I simplify it, divided by 2, it will be 5 over 18. Now, let me proceed to x equal to 2 means that I get the difference. I get the two number which their difference is 2. Let me erase this one first so that you won't get confused. So 1 can pair with 3. 3 minus 1 is equal to 2. 2 must be paired with 4. 3 must be paired with 5, and be careful, 3 can pair with 1 as well, because 5 minus 3 is equal to 2, 3 minus 1 is equal to 2 as well. So there are two possible outcomes here. So 4 can be paired with 6 and also 2. 5 can be paired with 3. 7 is not possible, right? Okay, and 6 can be paired with 4. Let me double check. Yes, correct. 1, 2, 3, 4, 5, 6, 7, 8. So it's actually equal to 8 over 36. So if I simplify it, divided by 2, okay, this one can be divided by 4, right? 2 over 9. Now, let's go to Px equal to 3. The difference this time will be 3. 1 paired with 4. 4 minus 1 is equal to 3. So 2 paired with 5. 3 paired with 6. 4 need to pair with 1. 5 paired with 2. And 6 paired with 3. All the different here are equal to 3. 1, 2, 3, 4, 5, 6. If I simplify, you will get 1 over 6 divided by 6 divided by 6. Okay, I have 2 more left. Let me do over here. X is equal to 4. The difference between the two values are equal to 4. So 1 paired with 5. 5 minus 1 is equal to 4. 2 paired with 6. 3, no, we cannot pair with any number here. So 4 cannot. 5, yes. 5 paired with 1. 6 paired with 1, 4, right? 2. Okay, 1, 2, 3, 4. So this is 4 over 36. If I divide it by 4, I will get 1 over 9. Okay, last one. P for x equal to 5. Let me write over here. Now the difference is maximum, which is 5. 1 with 6, 2 cannot, 3 cannot, and 4, 5, no, 6 plus 1. There's only 2 possible outcome over here. 2 over 36, which is equal to 1 divided by 2 divided by 2, you get 1 over 18. Now if you want to double check whether our answer correct or not, let's find the sum between all these possibility. The sum among these all probability. You should be able to get 1. If not 1, means that we did something wrong here. Okay, 1 over 6 and 5 over 1 over 6 plus 5 over 18, 5 over 18 plus and 2 over 9, 2 over 9 and plus 1 over 6, 1 over 6 plus, and I have 2 more, which is 1 over 9, and the last one 1 over 18. Okay, yes, it's equal to 1, means that we did it correctly. So you can fill in all the value here. So this is 1 over 6, this is 5 over 18, and this is 2 over 9, and this is 1 over 6, and this is 1 over 9, and the last one is 1 over 18. This is the answer for part A. Okay, draw a graph for the probability distribution of X. So I'm going to draw a graph to represent this probability distribution. Since I want to draw a graph, I think it's better that I change all the denominator here become the same first, so easier for me to draw the graph. How about I change all the denominator become 36? I just copy all of this. Okay, let me use this one first. Okay, I can make the number become smaller by not changing the denominator to 36, but I can change them all to 18, right? 18. Okay, so times 3 times 3, 3 over 18. This one I don't have to change anything, it's already 18 here. So this one I times 2 times 2, 4, 18, and times 3 times 3, 3 over 18, and this one multiplied by 2, it will be 2 over 18, and the last one, this one don't have to change anything. Okay, now all the denominator become the same, then it's easier for me to draw the graph. 1 2 3 4 5 3. Okay, so let me double check. Okay, correct. So what I'm going to do here, I draw an arrow here, vertical axis, and this is horizontal axis. This representing X means that 0, 1, 2, 3, 4, 5. Okay, and then this represents the probability. Okay, so this 0, and this is 1 over 18, and 2 over 18, 3 over 18, 4 over 18, the maximum is 5 over 18. Okay, 0 here, 1, 2, 3, 4, 5. Okay, let me plot the graph first. So for Px is equal to 0, 1 over 6, okay, 3 over 18. I'm going to make a cross here, 3 over 18. How about 1? 5 over 18, which is over here. How about 2? 4 over 18, 4 over 18, which is over here. And 3 over 18, same with this one. 4 and 2 over 18, which is here. And 5, 1 over 18, which is here. So what you need to do next, you just draw a vertical line like this. Okay, so if you want to double check again, you can find the sum of all these values. It should be equal to 1. If not equal to 1, means that we changed it incorrectly. Okay, so this is a way, this is the answer for B. For this video, I stop here first. See you next time. Thanks for watching. Bye bye.